Okay, good morning. Little video here to get you guys going on the 11A notes, starting with probability and stuff like that. Um, so if here's a scenario, we have a coin toss three times. How many possible heads, tails combinations can we have? Okay, well, if we're tossing a coin three times, well, a couple different ways we can look at it. I think it's, with this, it's kind of easier to sort of just do it and draw it out. So, we could have a heads, we could have a heads, tails. Okay. We could have, um, hang on, I did that wrong. Coin is tossed three times. So we could have heads, 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 tails, right? Heads, tails, heads, head, tail, tail. Okay. Then we could have tail, 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 head, tail, head, tail, and tail, head, head. Okay. So if we were to do that, okay, tossing a coin three times, the total number of combinations we could have is 8. Okay. These are the 8 possible scenarios that we could have. Okay, if we toss a coin three times, okay, we can get any of those things. Okay, the number of possible outcomes, we call that the sample space. Okay, all right. So the sample space is the number of possible outcomes given a certain scenario. So if we toss a coin three times, there's 8 total possible outcomes. Okay, and jumping down to this rule here, how we find that is if we want to find the total number of possible outcomes, we use the fundamental counting principle. It tells us we multiply each possible event at each stage of event. So here's what this means, okay? So we toss a coin three times, right? Okay, so we have our first toss, our second toss, and our third toss, okay? Well, on our first toss, we have 2 possible outcomes, heads or tails. On our second toss, we have 2 possible outcomes, heads or tails. On our third toss, we have 2 possible outcomes, heads or tails, okay? So if we toss a coin 3 times, okay, the sample space is 8, okay, because we have, we multiply each possible event. So we could either have heads or tails here. So there's 2 possible outcomes on the first event, 2 possible outcomes on the second one, 2 possible outcomes on the third one. So 2 times 2 times 2. Okay, so that's the sample space. These sample space problems here should be pretty simple for a deck of cards and a die because it's just how many possible things we have in there. And so what I want us to try is see if we could figure these out and figure these out. Find the sample space out. Again, all you're doing is multiplying um, how many possible things can happen at each different stage of the event. Okay. Now let's say, going on to the second page, now let's say we're trying to find the probability of 2 events that are totally independent. Okay, so we call it the probability of A and B. Okay. And these events are totally independent. Okay. So the probability of A and B both occur is the product of each probability, okay? PA and PB, okay? So what that means, I'm going to put this down here. So the probability of A and B is going to equal the probability of A times the probability of B if these 2 events are totally independent. Okay? So what that means, let's say we have, I don't know, let's say we have a die and we have let's say we have a die and we have a coin. Okay, let's say we want to do the probability of getting a 3 on the die and flipping a head for the coin. Okay, totally independent. So the probability of rolling a die, we get a 3, and then flipping a coin, we get heads. Okay, want a die? Okay, there's 6 possible things. There's 1, 3. So the probability of rolling a 3, if we roll a dice, is 1 out of 6. So the number is 1, 2, 3, 4, 5, 6. Right? If we flip a coin, the probability of heads is 1/2. Okay. So if we're thinking, okay, the probability if we throw a die and we get a 3 and the probability, we flip a coin and we get heads, is going to be 1/6 times 1/2, which is really 1/12. Okay. Now, let's say two events are not independent of each other. Okay. Then the probability of A and B is going to be the probability of A times the probability of B given A. Okay. Where B with the line through it, A, is a probability of B given that A has already occurred. All right. We'll talk about this when we get to classes. Right now, this formula is a little bit confusing. So, if the two events are not independent, then probability of A times the probability of B given A. We'll talk about it in class because that one's a little bit tricky, and it's easier to sort of explain in person than it is on a video. Um, so, independent. All right. If these are not independent, they're dependent on each other. We use this purple formula here. If they're totally independent, where they don't really, one doesn't really affect the other, we'll use that. Okay. Now let's talk about the probability of A or B happening. Okay. If A and B are independent of each other, okay, which sometimes they call that mutually exclusive is another term. Okay, which means A doesn't affect B or vice versa. Then the probability of A or B is going to be the probability of A plus the probability of B. Okay? The probability of A plus the probability of B. Okay. Now, if they're not mutually exclusive just means independent. So if they're not independent of each other, okay, then the probability of A or B is going to be the probability of A plus the probability of B again, but we're going to subtract the probability of A and B. Okay. Again, this is something we're going to talk about in class. Again, easier to talk about it in person than it is to do on a video. So if we want to just take some time, get these things done. If you want to try some of these problems out, you can, especially if you think, the two events are independent. If you find that the two events are independent, you could try the problems out. Just do the best you can. And we will go from there, and we'll talk about some of the stuff in class as we go. Okay? Y'all take care and have a good day.